Good morning, student. So today this is our third lecture on dual nature of radiation and matter. Now in today's lecture, first we will see wave particle duality of electromagnetic radiation. Means as far as electromagnetic radiation is concerned, it has a dual nature. In other words, as we know, light behaves like electromagnetic radiation. Ultimately, we want to prove that light has a dual nature. Light propagates either in the form of wave or light propagates in the form of what? Particle. So, if there comes a question in examination that explain wave particle duality of electromagnetic radiation, so always there is a confusion in your mind what to write, from where to start and where to come to end. So point wise, here we will discuss within 6 to 7 points. We can explain it in detail. The very first point, as you know, that light is, whenever light it comes or it interacts with the matter, then light behaves like that light is made up of bundles of energy or packets of energy. These discrete bundles of energy or packets of energy, they are called as quanta. They are called as what? Quanta. And later on, theoretically as well as what? Experimentally, it is proved that these quantas are associated with momentum. Remember, when I say that light is made up of bundles of energy or packets of energy, so the energy carried by quanta E equal to h nu. Energy is a property of particle, frequency is a property of wave. Means electromagnetic radiation possesses what? Wave nature as per this equation, E equal to h nu. But you can replace this energy as P into C, where P represents momentum and C is the speed of light, but momentum is property of particle. So there comes a question that whether this electromagnetic radiation or light, whether light possesses or light behaves like a particle or whether light behaves like a wave. Because sometimes light behaves like a wave, sometimes light behaves like a particle. Remember, as far as the light is concerned, light in general travels in the form of electromagnetic radiation. Light in general, whenever we say that light is traveling from one place to other place, it travels in the form of what? Electromagnetic radiation. In 1924, Compton, it is the name of scientist, who is performing an experiment on scattering of X-ray. Compton, while performing an experiment on scattering of X-ray by the electron in matter, he confirms the particle nature of light. He confirms what? Particle nature of light. Now, as far as Compton is concerned, again Compton proved that as far as electromagnetic radiations are concerned, electromagnetic radiations of particular frequency, electromagnetic radiations of what? Particular frequency will have same energy and momentum. Means if I say that electromagnetic radiation, they are of frequency nu, then the energy carried by each of the quanta is E equal to h nu or it is equal to P into C. So according to Compton, light behaves like a particle, means light is made up of bundles of energy, means light behaves like electromagnetic radiations, and if these electromagnetic radiations, they are of particular frequency, say nu, then each quanta will have the same amount of energy E equal to h nu and same momentum P equal to E divided by C. Same momentum P equal to what? P equal to E divided by C. Now remember, as far as light is concerned, light is made up of what? Photons. Light is made up of photons. They are bundles of energy or packets of energy, which we call it them as what? Photon. Now you know very well that photons are actually bundle of energy. Electrically it has no charge, means it is neither positively charged nor negatively charged, means electrically photons are neutral. And when photons are neutral, they are not deflected either by electric field or by what? Magnetic field. Photons are electrically neutral. They are not. Photons are not deflected either by electric field or by what? A magnetic field. Neither they are deflected by electric field nor they are deflected by what? Magnetic field. And remember that there occurs a collision between photons and particles, as we had seen that during the phenomena of photoelectric effect, actually the photon, which are the energetic particle, they are colliding with what? Free electrons in the metal surface. So there occurs a collision between photon and particle. What is that particle? Free electron. So photon and particles, they collide, and we know during the collision there will be a complete transfer of both momentum and energy from photon to that particle. So in photon particle collision, energy and momentum can be transferred from what? From photon to the particle. But remember that as far as the system of particle and photon is concerned, the net energy and momentum of the system, it remains conserved. It remains what? Conserved. Means if I say that I have a system which consists of n number of photons and n number of free electrons. So n photons, they are colliding with n electrons. So there is a complete transfer of energy and momentum of photon to the free electron. But what I am saying, that the system of photon and particle, that system, for that system, energy and momentum of that system remains what? Conserved. But as far as energy and momentum of the system is concerned, that energy and momentum of system is conserved. But remember, number of photons, they are not conserved. Number of photons, they are not conserved. Why they are not conserved? See here, at the moment when photons are colliding with electrons, these photons, they can be absorbed, or at the moment when we switch on the source of light, new photons can be created. Means photons can be absorbed or photons can be created. Photons can be absorbed and photons can be created. And these photons, when they are colliding with particle, during their collision, there will be a transfer of two things, that is energy and momentum will be transferred from photon to the particle. And remember, when the entire energy and momentum of photon is transferred to the particle, what happens to the photon? Photon will disappear because entire energy is transferred. Photon is nothing but bundle of energy. And when that entire energy as well as momentum is transferred to the particle, what happens to photon? Photon will disappear. So look at this. Photons can be absorbed or new photons can be created, and photons can transfer their energy and momentum during collision with particle and they will disappear. Now here again same thing, when we turn on the light, photons are created, and as far as photons are concerned, as soon as source of light is switched on, millions of photons will spread in all possible direction. And what happens to this photon? These photons, they will travel with a speed same as that of speed of light. Means photon can never be at rest. You cannot say that there is a photon which is at rest. Remember, photons are always traveling with a speed same as that of speed of light. Photons can never be at rest, and if you just want to find out the mass of a photon, just like you can find out the mass of particle in Newtonian mechanics. Here remember, you cannot find out the mass of photon. At the most, the rest mass of photon, it is taken as 0. Rest mass of photon is taken as what? 0. So that's why that in some of the experiment, just like the phenomena of interference and diffraction, you can perform the experiment in which you can observe the phenomena of interference and diffraction in a laboratory or in nature. So while performing this experiment, you can realize the effect of wave nature of light. See here, while performing an experiment on interference, that slit width or the distance of separation between the two slits, small d or slit width. So while performing an experiment on interference or diffraction, you can realize the wave nature of light provided that width of slit or the spacing between the two slits. Width of slit or spacing between the two slits, it should be small. It should be what? Smaller or comparable to the wavelength of light used. If that slit width or spacing between the two slits is smaller or comparable to the wavelength of light, then you can realize the wave nature of light. But by chance, if that slit width or the spacing between the two slits is made larger, then the interference and diffraction pattern will not remain same. Means you cannot realize the wave nature of light in case if slit width or spacing between two slits is what? More than the wavelength of light used. Now, as far as the scientists were concerned, that in order to explain the phenomena of light like interference or diffraction, which will be performed in the laboratory, or you can observe this in nature also. So to explain this phenomena, wave nature of light is useful. By using wave nature of light, you can explain both interference as well as what? The diffraction phenomena. So light in particular, electromagnetic radiation in general as a wave, means whenever you have to explain the phenomena like interference and diffraction, particularly you can consider light behaves like a wave, and in general you can say that electromagnetic radiation will also behave like a wave, because light is nothing but electromagnetic radiation. Whereas on the other hand, there are certain phenomena just like a photoelectric effect or black body radiation. As far as these phenomena are concerned, whenever you want to explain how that photoelectric effect occurs, or whenever you want to explain that black body radiation, spectrum of black body radiation, then these two phenomena, they can be explained just by considering what? Electromagnetic radiation consists of photon with a definite quantum of energy, means you have to consider particle nature of electromagnetic radiation. So the phenomena like interference, phenomena like photoelectric effect, phenomena like black body radiation, they can be explained by considering electromagnetic radiation as what? Particle in nature, because it can be explained by considering light is made up of bundles of energy or packets of energy called as what? Quanta. So some of the phenomena in physics like interference and diffraction can be explained by considering electromagnetic radiation possesses wave nature. Some of the phenomena in physics like photoelectric effect or black body radiation can be explained by considering what? Electromagnetic radiation as what? Particle nature. So also there are certain phenomena, to explain them both the nature of electromagnetic radiation is taken into consideration. Means there are certain phenomena in physics which can be explained by considering electromagnetic radiation has a wave nature as well as electromagnetic radiation as what? A particle nature. It is therefore necessary To keep both the physical model means you must have to keep into mind that electromagnetic radiation, it behaves like a wave nature, it behaves like a particle nature. So therefore, it is necessary to keep both the physical model to explain what? So many experimental observation, and there is a need. So that's why there comes a need to hypothesize. There is a need to hypothesize what? The dual character or dual nature of light. Dual character or dual nature of light. This phenomena is known as wave particle duality of electromagnetic radiation. So as far as explanation to the wave particle duality of electromagnetic radiation is concerned, you just try to explain it point wise as far as possible. Within 5 to 6 points you can summarize your answer. So here you can take a screenshot so that you can write your answer in your own word. Now let us see what is photocell, its principle, construction, working and application. Now as far as photocell is concerned, it works on the principle of photoelectric effect. It works on the principle of photoelectric effect. Now what is photoelectric effect? When I say that photocell works on photoelectric effect, it means it converts light energy into what? Electric energy. Photocell will convert light energy into an electric energy. Photocell, it works on photoelectric effect on the principle of what? Photoelectric effect, that is, it converts light energy into an electric energy. Now as far as photocell is concerned, what photocell consists of? It consists of, look at this, it consists of an evacuated glass bulb or evacuated quartz bulb. That bulb is made up of either a glass or a quartz. In that evacuated glass or quartz bulb, there are two electrodes are there. One of the electrode, which is made up of photosensitive material, and its shape is what? Semi-cylindrical in shape. So the electrode which is semi-cylindrical in shape and which is made up of photosensitive metals like cadmium sulfide, and as its function is to emit the electron, so it is known as an emitter, or it is also known as a cathode. There is one more electrode which is a loop of wire. It works as anode, and as it collects the electron, sometimes it is also known as a collector. So in a glass bulb or quartz bulb, there are two electrodes, cathode and anode. Cathode is known as emitter, anode is known as collector. Cathode is made up of, cathode is what? It is semi-cylindrical in shape and made up of what? Photosensitive metal like cadmium sulfide. Sometimes it is a semi-cylinder made up of any metal, but the inner surface of that semi-cylinder is coated with thin film of photosensitive material and which works as cathode, while a loop of wire may be of platinum. As it collects the electron, it works as a collector and also known as an anode. And look at this. These two electrodes in a bulb, they are connected in the external circuit with the help of these two pins. That external circuit consists of a high tension battery, that is a potential divider arrangement, along with a micro ammeter, and the function of micro ammeter is to measure the photoelectric current. Now as far as the working of this photocell is concerned, look at this. When incident radiation means light. So when incident radiation of suitable wavelength or suitable frequency, nu greater than nu 0 or lambda less than lambda 0, when incident radiation of suitable wavelength, that is lambda less than threshold wavelength lambda 0, or suitable frequency, that is nu greater than nu 0, is allowed to incident on the emitter of a photocell. We know photoelectrons are emitted. Photoelectrons are emitted by what? The emitter. And because here that anode is kept at positive potential with respect to cathode, means electric field is produced in a space between what? Anode and cathode. How is the direction of that electric field? It points from anode towards the cathode. So the electrons emitted by the emitter, due to presence of this electric field, they get accelerated and they get collected by the collector. So this flow of electron through the external part of circuit will produces a photoelectric current, and that photoelectric current is measured or recorded by the deflection of microammeter. Means we can measure the photoelectric current with the help of a microammeter. Remember that if I just keep the potential difference applied between collector and emitter is kept constant, means collector is kept at fixed positive potential with respect to that of what? An emitter. And if I change the intensity of incident radiation, what we will observe, that as we go on increasing the intensity of incident radiation, then photoelectric current will goes on increases, provided collector is kept at fixed positive potential with respect to that of what? An emitter. Now, where this photocell is used? In our day-to-day life, we can make use of photocell in so many applications. There are so many applications are there, but the most popular applications were lux meter. Do you know what is lux? Lux is SI unit of intensity of light, means you can measure the intensity of light in the unit of lux. What lux meter consists of? The same experimental setup. It works as a lux meter because you just allow the light of unknown intensity to fall on emitter. As per intensity of incident radiation, photoelectric current in a circuit may be more or less. If it is more, it means you come to know that intensity of light is more. If the pointer of microammeter shows less deflection, it means photoelectric current is small. Ultimately, it means intensity is small. So you can calibrate the scale of microammeter to measure the intensity of light directly in the unit of lux. Another important use, that is exposure meter. What is this exposure meter? It is a kind of meter which is provided along with a camera. In order to have a good photograph, intensity of light at that place, it should be proper. What exposure meter will do? That with the exposure meter, it is provided along with camera to measure the correct time of exposure. Means what? Remember, whenever we want to have a good photograph, the lens of camera, they must be exposed to light for a proper time. So the time interval for which the lens of camera will be exposed to light will be decided with the help of exposure meter. If intensity of light is what? Weak, through one of the window, light is allowed to fall on emitter, and if intensity of light is weak, photoelectric current is small. Photoelectric current is what? Small. It means you have to expose the lens of camera for long duration of time, and that is decided by exposure meter. You can reproduce the sound in cinefilm. As far as cinefilm is concerned, have you seen that pattern? Here you are having the visuals. So many visuals are there and that film is running, and on both the side you are having a coating of magnetic material, and over that coating of magnetic material, intense beam of light is allowed to fall, and that beam of light, after passing through that magnetic tape, it is allowed to fall on the emitter of a photocell. Remember, that as per sound recorded, here intensity of light is changing, means it will produces an electric signal of changing amplitude, and with the help of transducer you can convert that electric signal into what? Audio signal. In other words, you can say photocell, it can be used to reproduce sound in a movie. As we know that in order to switch on or off the street light, again we can make use of a photocell. Similar type of circuit is there. Along with this circuit, here we are having an arrangement in which photocell, there is no need of microammeter. So you can make use of photocell to switch on or switch off the street light. So long as day is there, light is continuously falling on emitter. Electrons were emitted by the emitter and there is a flow of electric current. So the street light which is connected in series with this circuit, it remains off during the daytime. During the night time, intensity of light falling on emitter is 0. No photoelectric current will flow, and the relay here, instead of microammeter, a relay, it is a device, a relay is connected, that relay gets activated and that street light, it turns on. Means so long as there is a night, that relay remains activated and street light, it remains on. Early in the morning, when the intensity of light changes from 0 to certain value, relay gets deactivated and that street light, it will turn off. So without any manpower, you can turn on and off the street light and you can save lot of energy. You can make use of photocell as a counter, because how many people they visited a mall or your house, you can count it. So for that purpose, what you have to do, suppose this is the entrance of a mall, and here at the bottom you will have a photocell, this circuit will be there at the bottom, and here you are having a source of ultraviolet radiations. Ultraviolet radiations, a source of ultraviolet radiation is there which is not visible to the human eyes. So that ultraviolet radiations, they were continuously allowed to incident on the emitter of a photocell. So there is a flow of photoelectric current. But as soon as a person enters the entrance of a mall, when person enters, then that ultraviolet radiations, they get interrupted. Means ultraviolet radiations, they won't fall on the emitter. So photoelectric current will break and counter circuit will count 1. Counter circuit will count 1. Similarly, you can make use of photocell as a burglar alarm. So for that purpose, what you have to do, suppose that here there is a safe which you want to prevent from stolen, and here you are having the entrance. On the back of the door, so long as the door will remain closed, here you are having a source of ultraviolet radiation, and from the source of ultraviolet radiation, here ultraviolet radiations were continuously incident on an emitter. When continuous ultraviolet radiations falls on the emitter of a photocell, we know that photocurrent flows through the circuit and that relay remains what? Off. Here, instead of bulb, you may have a speaker. So long as ultraviolet radiations were falling on a photocell, photocurrent is flowing through the circuit, relay remains deactivated and that alarm won't ring. Bell doesn't ring. But as soon as somebody opens the door in order to enter near to the safe, when door is open, what happens? These ultraviolet radiation and that person will be somewhere here near to the safe. So that ultraviolet radiations they get interrupted, means no ultraviolet radiations will fall on emitter, photoelectric current will become zero, relay gets activated and bell starts ringing, and you can prevent the things which are to be stolen by the burglar. Similarly, you can make use of photocell to identify the traffic law defaulter. There are certain people which will break the traffic laws. You know that, suppose here you are having a traffic signal and here red color bulb is switched on. So at the bottom you can generate electromagnetic radiation so that if someone tries to cross the road, when that red color bulb is on, then that ultraviolet radiations will be interrupted and you can count that how many people they had broken the traffic rules. So you can identify the traffic law defaulter by using photocell. By using what? Photocell. So let us now discuss what is de Broglie's hypothesis. In 1924, Prince Louis de Broglie suggested a new hypothesis which is based on the assumption that there exists a symmetry in the nature. In 1924, Prince Louis de Broglie suggested a hypothesis which is based on the assumption that there exists a symmetry in the nature, because we know that electromagnetic radiations they are dwell in nature. Electromagnetic radiation, as electromagnetic radiation has a dual nature, means electromagnetic radiation it behaves like a wave or sometimes it behaves like a particle. De Broglie know very well that there exists a symmetry in the nature, and by using the same assumption, de Broglie suggested that as far as matter is concerned, matter also possesses dual nature. Matter must have particle nature as well as matter must have a wave nature, of which particle nature of matter is known to everybody, because we know that matter is composed of a material particle. But as far as wave nature of matter is concerned, it was proved experimentally that Davison and Germer, they had proved that during their experiment on diffraction of electron by a nickel crystal, they proved that matter has what? Wave nature, means confirmation to the matter as a wave nature. It was given by Davison-Germer's experiment of diffraction of an electron by a nickel crystal. Now, as far as de Broglie is concerned, de Broglie says, or de Broglie made use of the wave properties like frequency and wavelength of a wave. De Broglie uses both a frequency and wavelength of wave, which are actually the wave properties, and he had connected these wave properties with the particle properties like energy and that of a momentum. De Broglie is able to connect the wave properties of wave, which are specified by frequency and wavelength. He used to connect it with the particle properties, that is properties of particle like energy and that of momentum. According to de Broglie, that the momentum associated with P represent what? The momentum associated with photon. Momentum associated with what? photon and which carries or whose total energy is E, means we are having a photon of momentum P carrying energy E. So momentum and energy of photon, they are related by the relation P is equal to E divided by C. P is equal to what? E divided by C. Now this relation, it holds good for all the massless particles which are moving with the speed of light. C represents the speed of light. So P equal to E by C. P equal to E by C. Here P gives us the momentum of photon having total energy E, and we know photons are massless particles moving with the speed of light C. Moving with the speed of light C. Now as far as this relation is concerned, what de Broglie suggests, this relation holds good for massless particles which are moving with speed of light. Now we know that as far as Einstein is concerned, according to Einstein's special theory of relativity, Einstein's special theory of relativity, now momentum of a photon P, which is equal to E divided by C. According to Einstein's theory, energy carried by a photon is equal to h into nu divided by c, where h represents Planck's constant and nu represents the frequency. But as we know that c is equal to nu into lambda. C is equal to what? Nu into lambda. So you can put the value of nu by c. It must be equal to 1 by lambda. So therefore P must be equal to h divided by lambda. P must be equal to h divided by lambda. Now as far as this relation is concerned, P equal to h divided by lambda. Remember one thing, from this relation, what de Broglie suggests, that a moving material particle, if there is a moving material particle having energy E and momentum P, according to de Broglie, as per this relation, any moving material particle of momentum P and energy E is associated with it a wave analogous to photon. Any material particle having momentum P and energy E has associated with it a wave which is analogous to that of a photon. And remember, the wave property and particle property of particle, the wave and particle property of a moving particle, it is also given by the similar relation. This relation itself gives us the relationship between the wave and particle property of what? Moving particle. Wave and particle property of matter. Wave and particle property of what? Moving particle. It was given by the same equation, P is equal to E divided by C, that is h nu divided by C, that is equal to what? H divided by lambda. Remember that if I say that there is a particle of mass m moving with velocity v, then the frequency nu and the wavelength lambda of moving particle, it can be given by the relation nu is equal to what I am saying, a moving particle of mass m, that particle is moving with velocity v, then the frequency and wavelength of moving particle, it is given by relation nu is equal to frequency, nu is equal to E divided by h, and wavelength lambda is equal to h divided by p. Wavelength lambda is equal to what? H divided by p. So you must remember this relation, that frequency and wavelength of any moving particle of mass m and velocity v will be given by nu equal to E divided by h, lambda equal to what? H divided by p. Lambda is equal to h divided by p, and we know that p is nothing but mass into velocity. So lambda is equal to h by p, or lambda is equal to h divided by m into v. Remember that the wave associated with moving material particle, what I am saying, wave associated with moving material particle is called matter waves, De Broglie defined a wave associated with moving material particle, he called it as a matter wave. And the wavelength of matter wave is called De Broglie's wavelength. Means the wavelength of wave associated with moving material particle, moving material particle is called De Broglie's wavelength, and it is given by relation lambda is equal to h divided by p, or it is equal to h divided by m into v. H divided by p, or it is equal to h divided by m into v. Now if I say that m is the mass of a particle of mass m, as already we have taken a particle of mass m, it is moving with velocity v. So definitely it possesses a kinetic energy. Let the kinetic energy possessed by a particle, let it be denoted by E suffix k. Then kinetic energy is equal to half m into v square. V is the velocity with which particle is moving. M is the mass of particle. Now from this relation, what is v is equal to? See here, 2 ek divided by m equal to v square. Therefore, v is equal to under root of 2 ek divided by m. 2 ek divided by m. So, the wavelength associated with that moving material particle, which is called as the De Broglie's wavelength, it is given by relation lambda is equal to h divided by m into v. That is h divided by m into under root of 2 ek divided by m, which is equal to h divided by m into under root of m divided by 2 ek. Now when I take this m inside that square root, it becomes m square. So this is equal to h into under root of m divided by m square into 2 ek. So this one m get cancelled, and we are lambda is equal to h in h divided by under root of, now what is left? 2m into ek. So the wavelength of moving particle, wavelength of any particle which is moving with velocity v, its De Broglie's wavelength is given by relation lambda equal to h divided by under root of 2m into ek. Now as far as this relationship for wavelength of moving particle is concerned, this relation holds good for electron, for proton, and even a charged ion. electron, proton or a charge ion. For these particles, that is electron, proton and charge ion, their de Broglie's wavelength is given by the relation lambda equal to h upon under root of 2m into Ek, where m represents the mass of a moving particle, mass of moving charged particle. M represents what? Mass of moving charged particle. Now, as far as this relation is concerned, if I say that if Q is the charge on a charged particle, if small q represent a charge on a charged particle which is accelerated, which is initially at rest, and it is accelerated to a potential difference V, a charged particle of charge q which is at rest and is accelerated through a potential difference V, then the work done by that charged particle which is at rest to accelerate through a potential difference V is work done W is equal to Q into V, and this work done will provide the kinetic energy. Means you can say kinetic energy is equal to work done is equal to Q into V. So you can put the value of kinetic energy here. So wavelength lambda is equal to h upon under root of 2m. Now in place of Ek, in place of kinetic energy, we can write what? That work done Q into V. Work done Q into V. So here in this equation, Q represent charge on a moving particle. V represent what? The potential difference through which that charged particle has moved. Remember, this relation, as already we had told you, that this relation holds good for electron, for proton and even a charge ion. And M represent the mass of moving charged particle, Q represent charge on a charged particle, and V represent the potential difference through which that charged particle has been accelerated. Remember that as far as this relation is concerned, it has a restriction, limitation, that this relation holds good if that potential difference V is in few volt. In order that this relation to hold good, what is the condition? That V must be in few volt. As soon as this potential difference V becomes large, means when potential difference is expressed in kilovolt, then that charged particle, it starts moving with a speed which is very near to that of speed of light, and under that condition this relation is not valid, it is not useful. This relation is not useful, it is not valid if charged particle is moving with a velocity which is near to that of speed of a light. So remember, whenever we apply this relation to find out the wavelength of a moving matter particle, moving particle of material, this relation holds good so long as this V is expressed in few volt. As soon as V becomes very high, that is in the range of kilovolt, that charged particle, it starts moving with a speed near to that of speed of light, and this relation does not hold good. So let us calculate what is that wavelength of an electron which is moved through a potential difference V. We know that the wavelength lambda means for an electron which is moving with velocity V through a potential difference V, an electron of charge E, mass M, moving with velocity V through a potential difference P, lambda is equal to, now what is the value of Planck's constant? 6.63 into 10 to the power minus 34 joule second upon under root of 2 into Mass of electron, approximately we are taking it as 9.1, but here in your textbook 9.11 into 10 raised to minus 31 kg is given. Q represent the charge on electron, so it is 1.6 into 10 to the power minus 19, and that potential difference V is kept as it is. And if you just calculate this with the help of calculator, it comes to be 1.228 into 10 to the power minus 9 upon under root of V in volt into what? This is expressed in meter. Or you can also express that wavelength in nanometer. So this 10 to the power minus 9 will disappear, and wavelength lambda is equal to 1.228 upon under root of V, and that is expressed in what? Nanometer. Expressed in what? Nanometer. Now, as far as this wavelength lambda is concerned, lambda equal to 1.228 upon under root of V. Remember that subatomic particles, electron is what? It is subatomic particle, while proton and neutron, they are what? The atomic particle. Both these subatomic particle like electron as well as atomic particle like proton and neutron, they exhibit what? They exhibit the wave nature. They possess the property of wave. They behave like a wave. They behave like a wave. So remember, lambda equal to 1.228 upon under root of V. This relation will give you the wavelength of, this relation will give you what? The wavelength of electron. De Broglie's wavelength of an electron, which undergoes a potential difference of what? V volt. When electron undergoes a potential difference of V volt, when electron moves from one point to other point having potential difference V, then the wavelength of de Broglie's wavelength of that electron is given by lambda equal to 1.228 upon under root of V. Upon under root of V. Now you remember 2-3 things, that as far as the de Broglie's hypothesis is concerned, de Broglie has given this hypothesis in 1928, and he got a Nobel Prize for this hypothesis in 1929. Later on in 1937, there are 3 scientists, Davison, Germer and that of Thomson. They received a Nobel Prize because they were able to prove that electron, which is a material particle, it also exhibits the wave nature. Also it is interesting that you can remember that Sir J.J. Thomson discovered electron. Discovery of electron by J.J. Thomson, and his son G.P. Thomson had proved that electron behaves like a wave. Wave nature of electron was proved by what was confirmed by the son G.P. Thomson of Sir J.J. Thomson. See the chronological order. De Broglie in 1929 proposed the hypothesis. So for that he got a Nobel Prize. Then in 1937, 3 people together, Davison, Germer, who had performed the diffraction experiment of an electron, and they got a Nobel Prize because they were able to prove that the electron will behave like, or electron possesses what? The wave nature. That is, wave nature of electron was confirmed by Davison, Germer's experiment along with J.J. Thomson, because J.J. Thomson has discovered the electron, and the wave nature of electron was confirmed by Davison and Germer. So in 1937, these 3 together they will get a Nobel. They got a Nobel Prize, and later on, the son of J.J. Thomson, who had discovered electron, his son G.P. Thomson had proved the wave nature of an electron. Wave nature of an electron.